All right, folks, it's Bass Action back in action. In this video, we're going to develop the unit circle. I'm going to go really fast, and the video is still going to be really, really long. So put on your seatbelts and just get ready, and know that you're probably going to need to pause the video and do some rewinding because we're going to cover a lot of stuff. All right, the first thing that I want to do here is I want to mark some angles around the circle. And what we're thinking about is a positive rotation, and we're going to be thinking about this in terms of radians. So I'm going to talk about degrees, and then we're going to flip it to radians. So let's start off with just the rotations at the ends of the XY axes. So as we start rotating around the circle, we would have a rotation of 0, of course. And we know that if we rotate half the circle, if we come all the way over to here and rotate half the circle, we would have gone pi radians, which means at the top of the y-axis, we would rotate pi over 2. And then now we can see that we're rotating as a pi over 2 each time. So 1 pi over 2, 2 pi over 2. That makes down here at the bottom of the y-axis a 3 pi over 2. Then, of course, if we kept going, we would end up with a 4 pi over 2, which would then reduce to a 2 pi. That's important because on the positive x-axis, we're going to think of that angle oftentimes as both a 0 and a 2 pi. Of course, I could write all these angles as a negative rotation, but that would certainly muddy the water here, so we're not going to add that to our grid. Now, the next thing that I want to do is I want to think about a 30-degree angle. So if I had a 30-degree angle, and this has been drawn to scale, I would end up right about there. Okay, now what you can do if you have a hard copy of this is we can connect this 30-degree angle all the way across here. So then what we would know is that if this angle here is 30 degrees, so is this angle. Now we can also identify that 30-degree angle right here, and I can connect that across my circle. And it's going to be important that all these angles would be a 30-degree reference angle. Okay, so what we want to do is we want to think, how could we label these 30-degree reference angles in terms of radians? So 30 degrees in terms of radians would be pi over 6. And then what we want to understand is this angle here is going to be 1 pi over 6 less than half the circle. This will be 1 pi over 6 more, and this will be 1 pi over 6 less than a full circle. So if we understand that half the circle is pi and write that in terms of a denominator of 6, then half the circle is 6 pi over 6, which means this angle right here is 5 pi over 6. If I'm going to go 1 pi over 6 more than 6 pi over 6, then this is 7 pi over 6. The whole circle then would be 12 pi over 6 to reduce to that 2 pi. So that means we need to go 1 pi over 6 less and have 11 pi over 6. Now, we can continue repeating that process, and I can go to the next angle up, and that would be a 45-degree angle. So my 45-degree angle is going to be pi over 4. And just like before, we can connect that across the circle. It's important to understand where these numbers are coming from. You definitely don't want to try to just memorize them all the way around the circle, because they really won't make any sense if you try to do that. So now if we have this pi over 4, again, we're going to think in terms of a half and a whole. So this would become 4 pi over 4. And now I need 1 pi over 4 less and 1 pi over 4 more. So this is going to become 3 pi over 4. And this is going to become 5 pi over 4. And lastly, this would be 8 pi over 4. So now I want to go 1 pi over 4 less, which makes this 7 pi over 4. The last angle that I'm going to do here is going to be my 60-degree angle. And again, we can connect that across. It helps you kind of see how these are going to connect. They're going to connect later as well. So I'm going to connect these. These are our remaining ones, are all going to be 60-degree reference angles. 60 degrees in terms of radians is pi over 3. And then I'm going to think on my ends, 3 pi over 3. So I'm going to go 1 pi over 3 less, 1 pi over 3 more. Makes this 2 pi over 3. This is going to be 4 pi over 3. And this is going to be 5 pi over 3 because it's 1 pi over 3 less than the whole circle that was 6 pi over 3. Now, whenever you're trying to draw a quick unit circle for yourself, don't try to write the numbers in the order around the circle. Try to write them in their groups, because then you can think in terms of a half circle and a whole circle, and it'll be easier for you. Okay, so that gets our angle measures around the circle. The next thing that we want to do is we want to understand the ordered pairs that would represent this if this was on a coordinate grid. So again, let's start at the ends of the XY axis. This point out here would be the point 1, 0, because a unit circle is going to be a circle that has a radius of 1 unit. So then at the top, we would have the ordered pair 0, 1. At the left, we would have the ordered pair -1, 0. And at the bottom of the y-axis, we would have the ordered pair 0, -1. Now, those are the nice clean numbers. What we want to understand are what are those values at the ends of those angles that we've just indicated. We have to understand there are ordered pairs all in between here, but these ones at our special angles are going to be important for us. So let's just start with the pi/4. And what I'm going to do in this upper left-hand corner is I'm going to draw a quick little triangle. From your geometry days, what you would have known is that if you had a triangle that had a right triangle, I don't know why I wrote a 5 there. If you had a right triangle that had a 45-degree angle, then if this was 45 degrees, then the sides of that triangle could be labeled as a 1, and a radical 2. That would reduce those values to their common ratios, their extended ratios for all 45, 45, 90 triangles. Now, when I look at this triangle, what I see is that the hypotenuse of this triangle has been labeled as a radical 2. But if we come over here to our unit circle, if I imagine that there's actually a triangle drawn in here, what I would want is I would want the hypotenuse of this nice 45, 45, 90 triangle. I want this hypotenuse to be a 1, and I know that this one's a square root of 2. So what I'm going to do is I'm going to divide everything in this triangle by a radical 2, which would make the hypotenuse a 1 and would make the legs a 1 over radical 2. Well, we would rationalize that, and we would get a radical 2 over 2. For each of the legs. That means that I would go over radical 2 over 2, up radical 2 over 2. So that means that on my unit circle over here, this ordered pair would be radical 2 over 2, comma, radical 2 over 2. That also means that over here, this ordered pair for the 3pi/4 is going to be the same, but the only thing that's going to change on it would be the signs of that ordered pair. The x-axis would become negative, but the y-axis would stay positive. These values stay the same, but their signs are going to shift as I move around the circle. That means that I could also go down to the 5pi/4, understanding it's the end of that red, and I could write those as a negative and a negative. So if I drew in this triangle, this ordered pair would be the same as this ordered pair, but the signs would simply change. I can do the last thing in my final quadrant, and I can write that then as a positive and a negative. So at the ends of all the reds, all the pi/4s, we're going to have radical 2 over 2, and all that will change each time is whether it's positive or negative. So if we want to write that same ordered pair with our signs in the first quadrant, we can do that. Okay, let's take a look real quick and see what we could do for the pi/6. So I'm going to come down into this bottom left corner, and I'm going to draw a right triangle with pi/6. We said that was 30 degrees, so I'm going to write a 30 degree. That makes this a 30, 60, 90. Across from the 30-degree angle, we call that the short leg, and we would always label that a 1 in geometry. The long leg got labeled a radical 3, and the hypotenuse was a 2. Well, now we're back to the same problem that we were with the 45-degree triangle. If I imagine this as a triangle, I need in the unit circle this hypotenuse to be a 1. Mine is a 2. So I'm going to rewrite this so that this is a 1, thus dividing every side of the triangle by 2. That means that this ordered pair can be written as a radical 3 over 2, comma, 1/2. Because when I look at my little triangle down here in the bottom left, I would go over radical 3 over 2, up 1/2. If I want to look at my last one, my 60-degree reference angle, I'm going to go in this bottom right-hand corner here. I'm going to draw that triangle. If this angle is 60 degrees, now the long leg and the short leg have flipped. This becomes the 1, this becomes the radical 3, and this becomes the 2. Again, we want to make that hypotenuse a 1, so we're going to divide each side by a 2, and we get the same values that we did for the blue or the 30 degrees, but the ordered pair flips. So I get a 1/2 radical 3 over 2. Okay, so that actually gets all of our values around the unit circles. So the things that you want to make sure that you understand is, first of all, remembering all these angles around the circle, and then being able to easily recreate or commit to memory what these ordered pairs would be every time it's a pi over 6 reference angle. So remember, that means that if this is a radical 3 over 2 comma 1/2, then so is this. All that changes is the sign. Now, on the bottom of this page, what I want to look at is I want to look at why these values are important for us. Okay, so if I come down here, what we're going to do is we're going to look at a general circle. So if I look at this general circle with a right triangle drawn in, and I call this angle right here theta, that's our common variable for an angle in trigonometry. If I call that theta, now I don't know whether it's 30, 60, or 45, it's just an angle, which makes the sides of this triangle an x and a y, and the radius of the circle is just r. I don't know for sure that it's a unit circle. If I do the Pythagorean theorem on this triangle, what I end up with is I get an x squared plus a y squared equals an r squared. If that equation looks like, that Pythagorean theorem looks like the equation for a circle, you're right, because we need to remember that the Pythagorean theorem, the distance formula, and the equation for a circle are actually all the same. Now if we think back to good old SOHCAHTOA from our geometry days as well, we can use this circle to understand our circle up above as well. So if I wanted to find the sine of this angle, this theta right here, I know from SOHCAHTOA that it's the opposite over the hypotenuse. So it would be y over r. In our unit circle up above, what we know is that the radius of our unit circle is a 1. So for our unit circle, the sine of theta simply reduces to y. Now, if you happen to have a calculator handy, what you could do is you could type in sine of 30 and you should get 1/2, and you'll get 1/2 because the sine at pi over 6 or 30 degrees, the y coordinate is 1/2. If you type in, for example, sine of 150, that puts you right here, you'll still get a 1/2. But if you type in a sine of 210, that puts you right here, you will now get a negative 1/2. So that's a nice way of being able to see and understand how this is working. I'm going to very quickly show us our formulas for the other ratios, and you could certainly take out your calculator and evaluate those as well. Cosine is going to be our adjacent over our hypotenuse, and then in the unit circle, that's going to reduce to a y. Tangent is going to be opposite over the adjacent, or y over x. That should look, by the way, like a rise over a run. And in fact, tangent is the slope of the radius at a particular point on the circle. We could also rewrite this then as sine theta, because y was sine, over cosine theta, because cosine was x. We can understand our reciprocal functions. We could reverse each of those. So cosecant is the reciprocal of sine, so I can write that as an r over a y. Secant's the reciprocal of cosine, so I can write that as an r over an x. And cotangent's the reciprocal of tangent, so it's going to be x over y. Okay, so we would just do the reciprocal of each of those ordered pairs, whichever coordinate we wanted. Now, I do often like to write the tangent values. So tangent of pi over 6 should be the y over the x, or in other words, our y coordinate at pi over 6, 1/2, divided by the x coordinate, which is going to be radical 3 over 2. And we can clean that up and write that as a 1/2 times 2 over radical 3, which is 1 over radical 3, and then just rationalize. So at pi over 6, the tangent, any pi over 6 reference angle, the tangent value will be radical 3 over 3. At pi over 3, I'm going to do the x coordinate over the y coordinate. And when I do that, I'm going to get my radical 3 over 2 times, I'm going to jump to the multiplication this time, the reciprocal 2, or a radical 3. So the last thing that we could do is we could come up here and we could add our tangent values. If we wanted, we could add those tangent values out to the side. So at pi over 6, the tangent value was radical 3 over 3. Just a nice little reference. At pi over 4, it's the y value over the x value, but since these are the same, the slope is going to be 1. And at pi over 3, we get radical 3. Okay, those are all the values and how we get them around the unit circle. And then from there, it's really just a matter of practicing with them in terms of whether they should be positive or negative. I could throw in one last little thing here, and it's a little phrase that we call all students take calculus. And what that tells us is that in this first quadrant, all of the ratios will be positive. The sine, the cosine, and the ratio are all positive. The reciprocals will behave the same. In the second quadrant, the only ratio that will be positive is sine, because that's the y coordinate, and it's reciprocal. All of the remaining ratios will be negative because they will all utilize this x coordinate. In the third quadrant, only tangent and its reciprocal will be negative, because we can get will be positive because the negative over the negative is positive. And in the last quadrant, cosine is the only positive ratio because it's the only one that uses only the positive ordered part of the ordered pair. Okay, so that's our unit circle. Practice that, study it, rewrite it as many times as you can.